Today, we're looking at an AI that can build and evolve software projects continuously, even outliving the individual AIs that created it. This is a massive step towards truly autonomous, long-term software development. Let's get into it. Let's start with a featured paper, Persistent Recursive Worlds Enable Autonomous Software Evolution, by Beichun Huang and Rancheng from Department of Data Science and Artificial Intelligence, the Hong Kong Polytechnic University. Genesis introduces the highly novel and impactful concept of persistent recursive worlds for autonomous software evolution, offering a paradigm shift in how agentic systems can manage and contribute to long-lived software projects. Here's a full breakdown.
Let's start in Panel C, which introduces the core idea of a persistent project. The persistent world's history shows how different software components, like the world root, evolve over time, outliving any single agent. Feeding into this, Panel A details how the system represents the software as a persistent recursive world. We can see the world root contains other worlds like ./API and ./web, creating a nested hierarchy for the project. Next, Panel B illustrates how agentic local changes are made within this structure. A transient agent is assigned a specific agent scope and objective to work on, producing a task result in an isolated environment. Finally, the system ensures accepted version advancement by integrating only validated changes, as shown back in Panel C. After the agent's work passes through validation, the changes are merged, advancing the persistent history to a new state like merge F6.8.2D41.
Up next, our second paper out of 3, Hidden in Plain Sight, Diffusion-Based Unrestricted Robotic Attacks on Vision Language Action Models by Zhehui Han and Xia Hu from Xi'an Jiaodong University. Dura introduces a highly impactful and concerning new class of unrestricted adversarial attacks on VLA models using diffusion, demonstrating a significant vulnerability that will likely shape future research in robotic security and robustness. Let's break down its key contributions.
Panel B illustrates our core idea, the diffusion-based robotic attack, or DURA, which creates a special diffusion mix trajectory. This yellow path represents a clever blend of a normal image generation process and an adversarial one, aiming to create a patch that looks natural but successfully tricks the robot. The proposed method, OURS, achieves perfect performance in white box target-only attacks across both simulated and physical environments, consistently outperforming TMA and FreeZevla. For black box target-only attacks, OURS demonstrates substantially superior performance compared to TMA and ES, with average scores of 86.0 in simulated and 79.3 in physical settings.
Up next, our third paper out of 3, Beyond Pixels, From Video Priors to 4D Worlds by Zihao Liu and Yi Yang from ReLER, CCAI, Zhejiang University. This paper explores a highly novel and potentially transformative approach to 4D generation by leveraging the denoised latents of existing video models, offering a more flexible and efficient paradigm. Let's break down its key contributions.
First, we take an input video and pass it through a VE encoder to get a compact latent representation. This latent is then fed into our L4AR network, which directly generates a 4D latent for the 4D decoder to produce the final 4D point map. Diving into our network, the process begins with the alignment stage, where a grid-align module directly maps the video latent to the 4D token grid. This is then passed through a 3D CONV layer to start building the spatial structure. Next, the refinement stage uses both frame attention and global attention to process the features across time. This step is crucial for ensuring the final 4D latent is spatiotemporally consistent and high quality. In the text to 4D task, our method achieves the highest scores in text clip and all Dino metrics, while being competitive in RGBref. For the image to 4D task, our method substantially outperforms all other baselines across all evaluated metrics, including text clip, RGBref, clip I, and all Dino scores.
Those were the top papers. Now, let's zoom out. ArXiv received 669 new computer science papers across 57 subfields today. Here are the trending areas shaping the field. Zooming out, the day's research clustered into 5 big themes: advancing LLM agents and reasoning, understanding real-world behavior and systems, uncertainty-aware ML for complex data, physics-informed and advanced ML, optimizing structured computational problems. The full paper list is in the pinned comment below. That's all for today's ArXiv Computer Science Daily. If you found this helpful, please leave a comment, and subscribe for daily paper summaries.
See you tomorrow.
Thank you to ArXiv for use of its open access interoperability.